let us talk about the Pythagoras condition. You need to understand about the Pythagoras condition because in your daily activities, like in carpentry or in building construction, you may need to construct right-angled triangles, even though you may not have the required instruments to construct the right triangle. But just by understanding the Pythagoras condition, then you can construct right triangles anywhere in your activities. Consider, look at this triangle here. It is a right-angled triangle. It has this side A labeled as A, this B, and this C. These two sides, side A and B, are the adjacent sides, and this is the hypotenuse side. Now, the Pythagoras condition states that the sum of squares of two adjacent sides equals to the square of the hypotenuse side. What this means is, if you take any triangle, like this, and if in that triangle you construct squares on the sides of the triangle, and suppose this length is A, this is B, and this is C, because these are supposed to be squares, this length will be A, and this will be B, and this will be C. So this area here, you may call it area B, will be B squared, B times B, and this, call it area A, it is going to be A squared, and this is area C, it is going to be C squared. So the sum of squares of the the sum of squares of the two adjacent sides will be equal to the square of the hypotenuse side. So this is the Pythagoras condition. Now, for any Pythagoras condition to exist, the sides should be in this ratio, ratio 3, ratio 4, ratio 5, meaning that one side should have 3 units, the second adjacent side should have 4 units, and the longest side, which is the hypotenuse side, should have 5 units. So the basic ratio that will make a right triangle is this: 3 ratio 4 ratio 5. Now looking up here, this is a right triangle here, from here up to here. This figure here is actually a right triangle. Now, if this side is 3, this is 4, and this is 5, and if you construct right triangles on the sides of this triangle, the sum of area A, area B will be equal to this area, meaning that area A will be 3 times 3, area B 4 times 4, and area C 5 times 5. So you can see the sum of these two sides, these two squares on this side on the adjacent sides makes 25, and the area of the hypotenuse side is 25. So by this ratio, the Pythagoras condition is satisfied. However, you can construct triangles of any size that will satisfy that condition. If you take this condition, 3 ratio 4 ratio 5, and if you take 3 ratio 4 ratio 5, you multiply by 2, and then again you multiply it by 3, and then you multiply by 4, here you will obtain 9, 12 ratio, this is 9, 8, it is 6, 8 ratio 10, and this will be 9, 12 ratio 15, and this will be 12, 16 ratio 20. You may go on multiplying the ratios by the numbers 5, 6, 8, and so on. All these ratios, 6, ratio 8, ratio 10, and the other ratios here, will make triangles which satisfy the Pythagoras condition. Just take this example here. If you take 6 squared plus 8 squared equals to 10 squared, this will give you 36 plus 64 equals to 100, which is 100 equals to 100. So you can see this satisfies condition, that condition. Also this will do, and this will do. So multiplying this basic ratio here by numbers such as 5, 6, 8, and so on, you will get ratios that will give you right-angled triangles. So you don't need to use instruments in most cases to construct right triangles. You just need to get to know this basic condition for obtaining any right triangle, and then if you want to get a triangle for any length, you multiply by these numbers, either 2, 3, 4, or 5, or 6, depending on the length of the figure you want to obtain. So I hope this clip will help you to think how you can obtain right triangles without even using instruments such as the protractors or other instruments that are used for construction of right angles, so that you can obtain right triangles.